Namaste, and welcome back to JEE Mathematics with Typical Monk. This is class 28, Mathematical Reasoning. Mathematics is built on statements, sentences that are cleanly true or false, never both. Join them with and, or, and if. Then, and their truth values follow strict mechanical rules that a truth table can settle every time. This chapter is pure marks. Negate a statement correctly. Know that a conditional equals its contrapositive but not its converse, and flip a quantifier the right way. No calculation, no formulas to derive, just clear, careful logic. Today, statements, connectives, implication, and the truth table. One idea at a time. Here is what you will master today. First, statements and their negation. Second, compound statements and or. Third, the conditional and the biconditional. Fourth, the converse, the inverse, and the contrapositive. And fifth, quantifiers, tautology, and validity, one idea at a time. Let us set the foundation. A statement. It is a sentence that is either true or false, but never both. Negation, written not P, it simply reverses the truth value of the statement. That are the compound statements joined by and or. If, then, or if and only if. Master line, a truth table, settles the truth value of every compound statement. Now look at the picture, the truth table of the conditional. The conditional, it is if P then Q, written P implies Q. False only once. The conditional is false in one case alone, when P is true and Q is false. Read the table. True and true gives true. True and false gives false. False and true gives true. False and false gives true. The vacuum is truth. Whenever P is false, the conditional is automatically true, no matter what Q is. Now the connectives and how to negate them. And is true. The conjunction P and Q is true only when both P and Q are true. Or is false. The disjunction P or Q is false only when both are false. De Morgan, the first. The negation of P and Q is not P or not Q. De Morgan, the second. The negation of P or Q is not P and not Q. The and the or swap under negation. Now the implication and its cousin. The conditional P implies Q, false only when P is true and Q is false. The equivalent form P implies Q is exactly the same as not P or Q. The biconditional P if and only if Q. It goes both ways. When it is true, the biconditional is true when both statements have the same truth value. The negation of the conditional not P implies Q becomes P and not Q, a conjunction, not another conditional. Now look at the picture. The four related forms. The converse, swap P and Q, giving Q implies P. The inverse, negate both, giving not P implies not Q. The contrapositive, swap and negate, giving not Q implies not P. The equivalence, a statement always equals its contrapositive, and the converse equals the inverse. But the statement does not equal its converse. Now, the quantifiers, the words for all and there exists. The universal. For all, every element satisfies the property. The existential. There exists. At least one element satisfies it. Negation of for all. It becomes there exists an element that does not. Negation of there exists. It becomes for all elements not. The rule, negating a quantifier flips it and negates the predicate that follows. Now three names for statements overall truth. Tautology, a statement that is always true, whatever the truth values of its parts. Contradiction, a statement that is always false, whatever the truth values. Contingency, a statement that is sometimes true and sometimes false. Now match each form to its meaning. P implies Q goes to if P then Q. P if and only if Q goes to the biconditional. Not Q implies not P goes to the contrapositive. and not P and Q goes to not P or not Q by De Morgan. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. The contrapositive is equivalent to the statement. Correct. Statement 2. The converse is equivalent to the statement. Wrong. The converse is equivalent to the inverse, not the statement. Statement 3. A conditional is false only when P is true and Q is false. Correct. So the answer 2 are correct. Statements 1 and 3. The trap is the converse in statement 2. Now the 2 mistakes that quietly cost marks. The truth, a statement is always equivalent to its contrapositive. The trap, thinking the converse is equivalent to the statement, it is not. The second truth, the negation of P implies Q is P and not Q. The second trap, writing the negation of a conditional as another conditional. In fact, it is a conjunction. Now, test yourself. Answer in your head before the reveal. That is how G speed is built. Here we go. Question 1. P implies Q is false only when P is true and Q is false. Question 2. The contrapositive of P implies Q, not Q implies not P. Cache, the negation of P and Q, not P or not Q. Question 4. A statement that is always true, a tautology. And question 5. The negation of for all. There exists, that does not. Let us gather it all in one breath. A statement is true or false, and negation flips its truth value, and is true only if both are true, or is false only if both are false. P implies Q is false only when P is true and Q is false, and it equals not P or Q. The contrapositive equals the statement, the converse equals the inverse. Negating a quantifier flips it and negates the predicate. Next class, relations and functions, domain, range, and the types of functions. Logic, cleanly reasoned. Mathematical reasoning asks for no calculation, only care. A statement is true or false. A truth table decides every compound of them. And a conditional is false, in one case alone, when the hypothesis holds but the conclusion fails. Remember that a statement always equals its contrapositive, but never its converse, and that negating a quantifier both flips it and negates what follows. Get these habits right, and this chapter becomes some of the most reliable marks in the paper. Next class, relations and functions. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you will crack G. I will see you in the next class.